Dear students, we had already done a little bit about acceleration and we had done about average velocity. As it is written, average velocity is total displacement by total time. Then acceleration means, like, suppose a body is moving at 50 meter per second with its velocity of initial velocity of 50 meter per second, and it goes to 70 meter per second in 4 seconds. So initial velocity is denoted as u and final velocity denoted as v, and change in velocity will be what? V minus u. And per second, that means we will be dividing it by how many seconds by using unitary method. So it has changed its velocity from 50 to 70, that is the difference is 20. So it has changed 20 meters in 4 seconds. So in 1 second, 20 by 4, that means 5 meter per second square. So I'm going to do this firstly, initially this sum, and then we'll come to the first equation of motion. So acceleration will be change in velocity, that is final velocity minus initial velocity by time. You can see my previous video in which I have told what is final velocity, initial velocity we denote by v and u. So a will be equal to 70 minus 50 by 4. So 20 by 4 is equal to 5 meter per second square. 5 meter per second square. Alright, 5 meter per second. So that is its acceleration. So we can derive the first equation of motion just using the same question. A body changes its velocity from u meter per second to v meter per second in t seconds. If we now put symbols, then we will get the first equation of motion. So I am deriving the first equation of motion first. A body changes its velocity from u meter per second to v meter per second in t seconds. In t seconds. So its acceleration is a is equal to v minus u by t. What is acceleration? Change in velocity. So you can write the statement change in velocity, then final velocity minus initial velocity by time, and you'll get this. Then at will be equal to v minus u. So v will be equal to u plus at. This will come this side. So this is the first equation of motion. Got it? So now suppose I have to derive the second equation of motion. So in the second equation of motion, everything will be same till here, but second equation of motion will deal with distance. So you just have a look by the time I get the duster. So now I'll rub this off, and now again the same whole statement has to be written for second equation of motion. This previous to this was first equation of motion. Now this will be second equation of motion, but you will write the same statement. Second equation of motion. Second equation of motion. Okay? So second equation of motion mein you will write everything the same. A body changes velocity from u meter per second to v meter per second in t seconds. So while doing this, it covers a distance of, s meter. So now I'll ask you a very simple question. Suppose a body has an average velocity of 50 meter per second. Average velocity is 50 meter per second. So what is the distance covered in 5 seconds? So 50 meter per second. So in 5 seconds it will be 250 meter. So that means the formula for distance covered will be average velocity into time. So average velocity into time. So now distance covered is s. Average velocity in this formula derivations you can use normally in numerical it is total displacement by total time, but for formula derivation you can write average velocity is equal to final velocity plus initial velocity by 2, that is v plus u by 2. So what will happen, let us see. S is equal to, now v in the first equation of motion, how much did we get? At. Suppose I take this as a, so at, u will come here, so v is equal to u plus at. That was the first equation of motion. So instead of v I will put u plus at and plus u into t by 2. What did we do? We replaced v is equal to u plus at from first equation of motion. So now see what will happen. U and u is 2u and t from the bracket it will be multiplied. So s is equal to 2ut plus at into t is at square, and then this 2 I can bifurcate because that is LCM. So 2 is cut. So we get a final second equation of motion s is equal to ut plus half at square. So this is our second equation of motion. Thank you.